Hello again. We are starting chapter 9 as I introduced yesterday, and it's about data collection. Specifically 9.1 and 9.2 are going to be about scatter plots. And I normally don't have you get your book out when I have a video, but you definitely need to have your textbook out. So if you do not have it out, get it out right now and hit that pause button. So now you've unpaused. So here we go. The reason why is because I'm going to be referring to the examples. I'm not going to be drawing them on my board, and I'm going to be talking about them. I'm going to have a very basic rough sketch, but you need the exact graph, and so that's why I need you being able to look in the book and look at the notes at the same time. So let's make sure you have that book open to 9.1, example 1. My hair is insanely long in this video. Anyways, here we go, scatter plots. So you guys got introduced to it yesterday in the activity and just figuring stuff out, trying to come up with what is this. You had to interpret it. You had to describe relationships. Some of you guys are like, well, what am I exactly talking about? And I said, that's coming tomorrow. So here it is. So scatter plot, let's first define that. Remember, we are in data chapter. So a scatter plot really is just a graph that shows a relationship between, now we could say this as two quantities or two data sets, but it's just a graph. Graph that shows, I have, I think, 3 or 4 vocab, so you should have out your pink highlighter. Graph that shows the relationship. Now, some of you guys might be asking, what do you mean by a relationship? That's what we're going to get to today. Between two quantities. We're not talking about parentheses, we're talking about where I'm at, right there. We're talking about two different data sets. And so in the activity, on the first part was talking about the circumference of the sports balls, and they're also talking about, I think it was the weight. I don't quite remember. That would be the two quantities that they were talking about yesterday. So was there a relationship between the weight and how far it is around? And there was one group in a class that said, well, what do you mean a relationship? And I said, we're going to talk about that. And then I said, do they have anything in common? So that's going to be another way that you can think about as the relationship of these two things. But also, the data sets, these two quantities, they are grouped as ordered pairs. Yeah, I'm just kind of looking at the definition here. So the two data sets are graphed as ordered pairs. That's why that activity you had to make so many ordered pairs. And by the way, we are not done graphing. So there you go. So definition's a little long. Okay, so graph that shows the relationship between two quantities. The two data sets are graphed as ordered pairs. So remember, quantity and data set, same thing. Just they're just using two different words. Okay. So here we go. First thing we're going to do is we're going to interpret a scatter plot, meaning we're going to be able to read it. What do we look for? That kind of stuff. And this is where I need you guys to be looking in your book. So if you still haven't gotten out your textbook, get out your textbook. 9.1, example 1, get it out. Hit pause, because I'm cruising. So we're going to interpret. We haven't done much interpreting graphs or slopes or anything like that, but when you interpret in math, what you're doing is you're putting words behind the mathematical meaning. So words behind 5/2, words behind the ordered pair 2, -5, something like that. So on this one, you have a scatter plot that shows, what is it, the amount of fat in grams and the number of calories in 12 restaurant sandwiches. So this is where you really need to look at the graph. So I'm just going to very quickly sketch this. Fat and calories. You can if you want to. You don't have to. Normally in class, I don't have you copy this at all. And so I'm going to have to kind of adjust since I'm not there with you guys. Okay, so 12 sandwiches. Okay, so here's what I did. And then I forgot about this thing. Okay, so like I said, very rough. X-axis is fat in grams. I didn't look at my label. That's why I'm looking at it over here. Grams. And then calories is up here. And so this is just going to be one data point. So that way I can refer back to, this is my way I'm going to refer the example back down to the book, if that makes sense. And it says we're looking at 12 restaurant sandwiches. Okay. Now there's this thing at the very bottom. That's a poor drawing of it, but take a look at it in the book. Now what that means, I just pointed to the book online. So if you look at this in the book, if you notice your scaling, your increments goes from 0 to 300. Okay. So this it's a zigzag. I call it a zigzag. Some people call it a lightning bolt. But if you see this in any of your axes when you're graphing, that means there's a break in the data. Meaning there's no values, there's no data points in between 0 and 300. And you could also have one for the x-axis. So this break is on the y-axis. Meaning there's not going to be any points, which is also known as a data point, that have less than 300 calories. But this is very important because if you don't have that, well, we'll talk about that later. How about that when I'm there? So that way I can get questions if you have them. All right, so part A is asking how many calories are in the sandwich that contains 17 grams of fat. So how many calories with 17 grams of fat? Okay, so let's pretend this is the point, okay? And this is the point that I'm going to use, but I want you looking in the actual book. So you're going to find the point where you're going to follow down here, your increments, and it goes by 5. So let's go, it's, 5, 10, 15, 20, squeaking that one in there. And actually, mine's not too bad. And so you're going to follow this up. And then we want to know how many calories it has. So that means then you're going to follow it this way. So follow it up from where 17 is. And since this scale is in 5s, you're going to have to estimate it. It's going to be closer to 15, but not on that side, meaning closer to 20. Okay, so you follow it up. And once you follow that across, wherever it hits here is going to be the number of calories you have. So if I'm looking up, I'm going to estimate that, and I'm going to follow it across, and you should have hit 400 calories. Okay, so that's where it's going to be over here. Now, B is saying how many grams of fat are in a sandwich that contains 600 calories. So how much fat? And I'm really shortening this up with 600 calories. Okay. Like I said, you can write this down if you want, or if you just want to follow with me on the video, I'm leaving that part up to you. We're far enough into the year where you should, especially on videos, if you want to do your own thing. I don't know if that's a good thing to say or not. But anyways, here we go. So on this one, you're going to follow up here to where it's 600. So let's say that's 600. Okay. So you're going to go 600 here. Then you're going to follow this way until you hit a data point. And then where is that? So 600. And then you're going to follow it down. And let's just say it ended right there. Okay. Till you hit the point. Boink. And then you're going to follow it down here. So you're going to start at 600, follow till you hit the data point, and then follow it down. And that data point, when I'm looking up over here, you should have hit at 30 grams of fat. And I know you guys have had a sandwich or 2 or 3 or 4 or 5. And so if you take a look at the graphs, and so I'm looking at the ones on the book online. So if you notice, there's nothing down in this area. There's nothing kind of down in that area. Okay? So what this is showing is there's no data points, there's no sandwiches that have fewer grams of fat and fewer calories. Okay? It's generally, like up in here, that kind of stuff. But you also don't see up here. So if you had a data point up here, what this would be saying is there's very few fat grams, but really high in calories. And if you've had Mr. Hensley enough, you know what fat and calories mean. The reason why there's no sandwich up here that has a ton of calories with few grams of fat is because fat is flavor. Like bacon. Why is bacon so good? Because it's got so much fat in it. Those of you guys who eat bacon. So you don't see points over there. And just like you don't see points, over here, where there's a lot of fat and fewer calories. That it just doesn't happen that way. Because remember, a fat gram has 9 calories. So that's something to remember as well. So that's how you interpret it. So it depends on if you read x-axis first, you're going to follow that up till you hit a data point, and then you're going to follow it across. If you want to follow by calories, you'll come up here first, follow it horizontally, if you like that word, till you hit a data point, then follow it down. And that is how you interpret a scatter plot. So you're putting words behind the data points. And so this is showing the fat grams and the calories for sandwiches, and if there's a relationship or not, which is what we're going to do coming up. Pardon me. I can't hit pause on here or else I have to redo the whole thing, so I apologize. Okay, now, so part C says what tends to happen in the number of calories as the number of grams of fat increase. So if you look at your graph, I'm not going to do it here, but if you look at your graph, as the number of calories, wait, are we doing calories first? So what happens to the number of calories as your fat increases? Well, the more fat you have, the more calories you tend to have, because fat is flavor, fat has calories, so it's added up here, okay? So the more fat you have, generally the more calories the sandwiches are gonna be. Okay, that was part C. Okay, next up, we're gonna actually start talking about relationships in scatter plots. And I know I've talked about relationships and functions, right? X and Y are in a relationship because it helped us remember that an ordered pair is now known as a relation. But in scatter plots, since data, this is all data stuff, scatter plots have relationships because you're trying to figure out, here's what relationship means. If the two things that you're comparing, if the two things that you're organizing data-wise, whatever's on the x-axis and whatever's on the y-axis, if they have anything to do with each other, that's what your activity was trying to show. Did the, and there was the sports balls, did the circumference have anything to do with the weight? And that's why they asked you about that bowling ball. Okay, they're trying to figure out if the two things have anything to do with each other. I'm going to give you examples here. So you're going to draw 4 one-quadrant coordinate planes, okay? This is going to be really weird, okay? Draw something like this, okay? And so when I do this, it's going to get a little noisy in class, so I apologize to the sub. But you're going to draw a graph that looks like this. And so all of these are technically data points. I'm comparing this and I'm comparing this. Okay, so this is just a very basic graph. Okay, so you're going to make one that looks like that. And if you have to hit pause, that's fine. But we're going to identify the relationships. There's 4 different types pardon me, of relationships you can have when it comes to data collection and scatter plots specifically. So here's what we do when we're identifying relationships. We start with, does it look more like a line or more not like a line? And hopefully you said that's more like a line. So this is going to be a linear relationship. And then you want to ask, are the points generally going up? You could say, you know, I mean the word up. Or are the points generally falling? And here you would say most of the points are generally rising. So this is actually technically, it's a positive linear relationship. Okay, positive linear relationship because it looks more like a line and the points are generally rising. So scatter plots and data collection, it's, I don't want to say never, but 99%, no, 90%. Most of the time, it's not concrete, it's not abstract. It's not, no, it is abstract, it's not linear. Because if it's linear, it's gonna, all these data points are going to be on a line, and that change between each one of these points is going to be identical. You can have data that does that, but generally that's not the case. Okay, next one. Talked a lot on that one. So now you're going to draw one that looks like this. And don't be obnoxious in class when you're copying this. So now here's where we're going to start. Does it look more like a line or more not like a line? Hopefully you said more like a line. And I know you don't have anything to judge it off of right now, but that's okay. And then you're going to ask, are the points generally rising or are the points generally falling? Hopefully you said falling. So this is a negative linear relationship. Okay. More like a line. More like a line. Okay. Now here's the next one. This one's always harder for me to draw. I've been doing this how many years and I still have a hard time with it. Okay. So now you can see all three of them. We're going to start with the same place I did with the other two. Does this look more like a line or more not like a line? And hopefully I did that. That's not that bad. Hopefully I did that exaggerated enough. And so hopefully you said on this one it looks more not like a line, because that's what I was going for. Okay, so this is going to be a non-linear relationship. Okay. Now, on non-linears, you could say, are they rising or are they falling? But generally in Math 8, we just say it's non-linear. So, non-linear relationship. Okay. And your points could also be doing this as well. Sorry, you see that. Your points could be doing this as well. Okay. So it looks not like a line. So this whole chapter is pretty much gray area. I talk about the colors of math, and most things are black and white. You start, there's a problem, there's an answer. This is gray because it's not necessarily the exact answer. Sometimes it is, sometimes it's not. It's hard. Data is fun though. I like data. But I was also a science major, so. Last one. Draw something that looks like that. And you start in the same place. Does this look more like a line or more not like a line? Hopefully you said not like a line. But does it look like this? No. Could this even form anything that you guys are familiar with that we've done this year in class? No. So this is what we call no relationship. Okay? No relationship. So these are the 4 different type of relationships you're going to see in Math 8. And to give you examples, that's coming up in the next part of this, which is going to be example 2, which I have a couple more words to define for you. So I'm going to erase this. Remember, you can always hit pause. So now we're going to get down to the nitty and gritty. Like, let's start talking about like the 2 different data points, not data points, the 2 different data sets, also known as the 2 quantities. I'm going to use both terminology so you get comfortable with it, because some books do say data sets, some activities say data sets, some say quantities. So I just want you comfortable with all of this stuff. Okay, so now in example 2, you're going to have 3 new words, and these are specific to the data points. One of them is cluster. Now, I'm talking about a cluster on a scatter plot. And if you think of the word cluster of anything, like you have a cluster of shoes in the corner of your room. Hopefully you're thinking of, you have a lot of the same thing. Okay? So a cluster is data points that are close to each other. So what that means is each data point is going to be very similar to the next data point. And I'm not going to do examples because that's the whole point of example 2. Okay? Data points that are close to each other. The next one is a gap. Okay. And then so when we're talking about a gap in a scatter plot is really, it's a hole. It's a hole in the data where there's no information. So, a hole in the data with no information. You might also hear me say it's a break in the data. There's There's no data points that are close to anything, so that's why there's a big gap. It looks like just a big white space, to be honest. And then your last one is called an outlier. And for years, I would always ask you guys if you've read the outlier. And I know at one point, Mr. Roscoe's class used to read this and then be like, oh, we talk about the book and okay, well, what does it mean? What did it mean in relation to that book? And if you guys do read it, I apologize. But an outlier is something that stands on its own. Okay, so I guess in that book, it was a character that was just not conforming to others. I don't quite remember. I didn't read it. And so, sorry, this keeps glitching out on me. So an outlier is a data point that's really far removed from the other data points. And to me, I think of it's really obvious that's not belonging to the other data points. Okay, so a data point. I like far removed, but maybe that's just because that's what I'm used to from my science background. But really what it is, it differs significantly. Ooh, significantly. From other data points. Okay, so a data point differs significantly, I can't read that one backwards, from other data points. Just think of it, it's kind of on its own, whether it's above or below, but it's got to be obvious. That's the thing. All three have to be obvious. That's how you can identify them. Okay, all three have to. That's what you want to look for. It's the point that stands on its own. It's the group of data points that are all right next to each other. It looks like just a blob of points, kind of a thing. And with a gap, it's an obvious break because it's white. There's no other data points, that kind of thing. So these three vocab, so it's gonna be pink, and then this guy, it's a bubble, so you guys should know that's blue. Okay. And so we're getting ready on example 2. Okay, and again, I'm not, I don't know if I should do that. Okay, what I'm going to do is I'm going to very, very roughly draw these. But example 2 is identifying all this information. Now that we've got specifics on what to look for in data points, now we're going to be identifying them. So example 2 is describe the relationship. So we're going to use the, does it look more like a line? Does it look not like a line? That kind of thing. Describe relationship. Outliers, gaps, and clusters. Okay, when it comes to data, there's no rules. No rules. You don't have to have a cluster. You don't have to have a gap. There doesn't have to be an outlier. Data is just data. It's information that's gathered. And I love me some data collection. We're going to do some of that. Okay, so this is example 2. Describe the relationship. Identify. I forgot the word identify. Identify. That should be right here. Identify outliers, gaps, and clusters. So 2A. We're looking at 2A. So like I said, I'm going to rough draw this. So this is TV size and price, money. Okay. So this is inches. And it looks, oof. It looks very, very roughly like that. Okay. Like I said, you don't need to copy this. Okay. So now we are going to just, first of all, talk about the relationship. We're going to identify if there's a relationship. This is about TV size and how much it costs. And I know you guys aren't really generally shopping for TVs. Maybe you have bought a TV yourself. But let's think about this logically. As the size of the TV increases, what do you think is going to happen dollar-wise? I hope you said it's going to cost more. Yeah, because the bigger it is, the more money it costs. Is that always the case? No. Okay, so relationship. Does this look more like a line or more not like a line? Remember, I'm not really making sure you see this because I want you looking in the book. I keep pointing over here because that's where my screen is. Like a line, not like a line? Actually, this one is more what they would call a positive linear relationship. positive linear relationship. Okay. Then identify gaps, outliers, and clusters. Okay, so let's start with outliers. Okay, so we're looking for a point that's far removed, or it's really obvious that it's out there on its own. Hopefully you're looking at the graph and not mine, because mine's really not pretty looking. So you see there's a point out there on its own. You should have identified one. And yes, there is one, but you don't just say outlier yes. What you do is you identify where it is by its coordinate. And so I'm looking over here. That looks like it's at 70. And you're going to follow it across to the price. And I'm looking, so it's in between 2,000 and 2,500. So I'm, you know what, a good guess. Hopefully you said like 2,200, 2,250, something like that. If you said 50, that would be wrong, because there's not a point at 50. That's an outlier. Okay, but 2,250, if you put 2,100, it's a little more than 2,100. If you put 2,400, it's not quite that much. You know, good solid middle. Okay, that's where I would identify my outlier, because it's not exact. I mean, 500 is an itty bitty little space like that. So of course we're not going to know the exact. Now gap. Let's identify a gap. So do you see an obvious break in the data? Do you see an obvious big white space? That's what we're looking for. And again, I'm looking in the textbook. Yes, there's one gap. Okay, so now we got to identify where it is. So when you identify, since we have to list coordinates, and a gap isn't necessarily a coordinate, it's an area, you can either define it by where it is located x-wise or y-wise. Sometimes it's easier to go for y, sometimes it's easier to go for x. So I'm looking at the gap. If you went by TV size, we're looking at like 33-ish to 40. That's where I'd say the gap is x-wise. But for me, it's much easier to look at it from the y-axis. So I'd say it's about 500 to, hopefully you said 1,500. Okay, so gap, 500 to 1,500. That's what I would write down. Okay, and it's not an ordered pair, because remember, it's a space. It's a space. Okay, and then cluster. Okay, so you're looking for a cluster. You're looking for a lot of data points right next to each other. They could be an exact data point, or there could be so many of them, or just like a blob. So that's what we're looking for. Do you see any of those? Yes, there is a cluster. And it's around what? Now remember, we have to describe the area, because it's not just one data point. So around the area, for me, it looks like it's going to be easier to identify using my x-axis. So TV size, where would you guys say that's around? Remember, you're looking in your book. I'd say around 30 inches. Okay. Okay. So yeah, I just put around 30 inches. You could have also described that money-wise. So you would say, for if you want to use your y-axis, you would say it would be, you know, I'd say around $500. You could even say something like, you know, from like 250 to 500. That's getting a little too much. That's not needed. Yeah, for me that was easier to identify using the x-axis. So there you go. You just identify the relationship because it looks more like a line and it's generally rising, so it's positive linear. Meaning, I don't know if I went over what the meaning is. If it's a positive linear relationship, that means as x increases, y increases. That's the positive part. Your outlier, gap, and cluster. Okay, so let's say there was no gap, you would write no gap. Okay, you need to identify that there is not a gap in the data. You can't just forget it, because it looks like you just forgot to do that part. So if you don't have one of these, but put no outlier, no gap, no cluster. Okay, next one. Okay, oh, this is fun. Age and pets owned, 2B. So person's age and then number pets owned. Something like that. Okay? So you have to look, does it look more like a line or does it look more not like a line? And hopefully you said it doesn't look like anything, because it shouldn't. So this is, I'm going to write it over here, no relationship. Okay? Ooh, this is a long video. No relationship. So if there's no relationship, what that means is these two things you're talking about have nothing to do with each other. Unless you're me. And if you've been paying attention, you know that I have a lot of pets right now. I have a lot. I have like 50 some odd pets right now. That's including all my fish. So I would definitely mess up this data. Okay? So here's what it's saying. The person's age. Now you can interpret this two different ways. So I'm looking at the graph. The person's age and the number of pets owned. So if you look at a data point, 10-3, that was someone was 10 years old and they had 3 pets owned. Okay? But someone could be 30 years old and not have any pets. So does your age have anything to do with how many pets you own? No, it does not, because it's not a requirement. They don't depend on each other. Ooh, that's a good one. We're using our function language. So there's no relationship because these have nothing to do with each other. Okay? So if we're looking for outliers, this is where I would mess up this data, because I'm, like here-ish on age, but I would be so far up here, I'd be way up here, because I have had hundreds of pets in my life. Hundreds, because I grew up with a lot of pets. So I would be an outlier if I was included in this data. But in this graph, if you look at an outlier, some of you guys might say, well, yeah, there's a bunch of them. But remember, an outlier has to be significantly removed from the data. That's why me, way up here, I would be considered an outlier for this data. But I'm not part of this data. So on this, there's no outliers. Okay? And generally, you're not going to have outliers when you have a data set that has no relationship, because there's nothing to do with each other. And do you see any obvious clusters? You can have, I don't know why I held up my board. You're looking at your book. Do you see obvious clusters? Because I see 2 spots where 2 data points are close, but they're not like a cluster. So outliers, no. Clusters, no. And last one, gaps. And some of you guys might look at the graph and go, yeah, there's a bunch of gaps. Remember, a gap is an area where there's no data. It's like a hole in the data. But since this data is all over the place, you can't define the space where there's no data. So you would say no gaps. So there's no outliers, there's no clusters, and there's no gaps. However, if I was part of this data, you would have an outlier way up here. And so outlier, you would identify it by its ordered pair. So generally speaking, at this age, for Math 8, if you're talking about a no relationship graph, you don't have any outliers, you generally don't have any clusters, and you generally don't have any gaps. The only one I tend to see more of in a no relationship graph is clusters, because it's just coincidence. Okay, so another no relationship graph would be like what you ate for breakfast and how many stoplights you had to go through to get to school. They have nothing to do with each other. So that would be an example of no relationship. I'm not going to give you a relationship of one for positive linear because we have a really big project on that. Well, it's not really big, but it's just fun. But negative relationship would be money and time. Bank account. As time goes on, you generally have less money in your account because you're using more money until payday. So that would be an example of negative linear relationship. So I'm not going to do one for the curve because we generally don't see those. So, okay. That's a long video. I'm at 35 minutes already. So that is your introduction to scatter plots. Next up, what we're going to do is then use the data to try and extract. Ooh, I don't want to use that word yet. We're going to apply a linear model to it so we can use that to make predictions. So that's the second part of scatter plots. All right, you're off on your homework. Have a good one. Bye.